Everyone knows that the ocean is salty, with millions of Americans relying on the coast and coastal waters for homes, food, businesses, and transportation. It's important to monitor the variability of the salinity of coastal waters and bays to help create models to help predict the impact of any changes in salinity.
One water body that's particularly sensitive to changes in salinity is Biscayne Bay, located south of Miami. The bay covers 428 square miles and began forming 3,000 to 5,000 years ago as sea levels rose and flooded South Florida. One way to understand the changes in salinity of the bay and to predict future changes is to create a simple model. The first step is to gather and analyze data, not just salinity, but also wind speed, air temperature, and several measures of atmospheric moisture. We also need stream flow and sea level data, as well as precipitation and evaporation rates. We had 15 years of data to work with. Now, in order to create the model, we need to know what drives salinity variations in the bay. This was done by computing both a freshwater budget and a saltwater budget for the bay using what's called a box model, which is essentially a set of equations that describes the flow of some quantity in and out of an area, where the areas are represented visually by boxes. In this case, the box we're focused on is Biscayne Bay, and the model takes into account the area of the bay and the rates of evaporation, precipitation, stream flow, and net freshwater flux into and out of the bay. The box here in the middle represents Biscayne Bay. The box on the left, the land, and on the right is the open ocean. The green arrows represent the flow of water going into the bay. There are two sources of fresh water into the bay. On the left is the stream flow from canals emptying into the bay. Another source of fresh water into the bay is precipitation. And finally, there's the salt water flowing from the ocean into the bay. Now the flow of water leaving the bay is represented by the red arrows. There's evaporation from the surface of the bay itself, and also the flux of water out of the bay back to the open ocean. If you know the amount of water associated with these 5 arrows, you can model changes in the salinity of the bay. One conclusion that comes from the observations is that when stream flow values are high, the salinity is low, and vice versa. This isn't that surprising, and you can see this by plotting the seasonal trends in salinity and stream flow averaged over the 15 years. Salinity reaches its peak in the spring when stream flows are low, and reaches its minimum in the fall when stream flows are high. Another conclusion is that the observations show that the salinity in Biscayne Bay has gradually increased from 1993 to 2008. Our salinity model was able to fairly accurately capture the freshwater flux in and out of the bay, and also as a result was able to capture this salinity increase. Here, the salinity predicted by the model is in pink, and the observed salinity is in black. The closeness of these two lines tells us that the model has predictive value and suggests that we can use the model to get a sense for future salinity values in the bay. Finally, we use the model to compute the so-called exchange timescale of the bay. To understand this concept, imagine that all the freshwater input to the bay stopped. The exchange timescale is how long it would take for the bay to become as salty as the ocean. For Biscayne Bay, this is about a month. This is important because since salinity is increasing, freshwater input to the bay must be decreasing. This value gives us a sense for how long it would take for the bay to consist of all salty water if the freshwater input completely stopped, for example, due to drought. Knowing this time frame could help in the formulation of a plan to reverse these effects if necessary. Even though we don't have all the answers right now, we know that salinity is changing and certain areas are more vulnerable to those changes, including South Florida. With the help of models to predict salinity changes over time, authorities can establish a plan to restore and rejuvenate the ecosystem of the Biscayne Bay and possibly similar endangered areas around the world.
Further research into the impacts of these changes will allow better prediction and planning to keep coastal ecosystems healthy well into the future. My research this summer, done while at Penn State, was sponsored by the National Science Foundation through a research experience for undergraduates program.